Hello, my name is Tracy Kump. I'm the Wet Chemistry Lab Manager here at Cincinnati Waterworks, and we are in the Wet Chemistry Lab. And this is basically our central hub for process control for the treatment plant. So every day we'll bring back samples at different points throughout the process, and we'll bring them back here to analyze for things like pH, chlorine, fluoride, alkalinity, hardness, and turbidity. Those are the main ones, and then there are a few additionals that we can analyze for as well. Once we get the results, we are able to tell if the treatment plant is operating optimally. We do add treatment chemicals throughout the process, and those parameters help us identify where we need to make adjustments. So this is our SCADA screen, and this screen is basically delivering us live readings from our monitors throughout the process, all the way from our raw water in the Ohio River, all the way to our finished water that's heading out into the distribution system. So we've got different monitors for different parameters at each location, and we're able to get live feedback as the water's moving throughout. So let me walk around the lab real quick. I'll give you a quick tour. We do have some sample taps on the left here for our finished water. And then a couple of the stations here, we've got our chlorine titrator, pH, and then walking around the bench here, our turbidity, alkalinity, fluoride, and hardness. A lot of these are simple titrations, a little bit less complex analyses. But again, this lab is very important to maintain proper treatment throughout the treatment process. So that's basically it. And we probably analyze a few hundred samples every week. So there's a lot of samples that move through here, and we do some compliance sampling as well. So I hope that covered everything. It's a busy lab usually, and we've emptied everybody out so we can get in here and do this mask lift. So.
I'm Tricia Klinicki. I'm an analyst here in the microbiology lab at Greater Cincinnati Waterworks, and I want to kind of show you what we do here. We test for compliance. We test compliance samples, and we also test microbiology samples for process control. One analysis we do, is coliform analysis. We actually collect over 3,000 samples a year for water from the distribution system. And that water is the water that would go from the plant to your house. And we do this analysis. It's a presence-absence analysis. If the sample is positive for total coliform, it turns this purple. If it's negative, it's yellow. And we can also do counts on this if we need to. This is also a test that we do on samples that valve operators will collect from depressurizations or when new mains are put in. We also do analyses for other process control like heterotrophic plate count and aerobic endospores. In addition to the microbiological analyses that we do on water from the distribution system, we also do analysis of algae using our microscopes here. And this is to keep track of what's going on in the Ohio River and at different places through the plant. Ohio River grows algae. We've had some blooms on it, and algae can produce taste and odor compounds. They can also produce toxins. So we want to keep an eye on what's going on in the river. So you can see from some of these photos, these are some of the things we've seen. We have all sorts of different structures. They can be colonial like this one, and this is actually a good example of one that does produce a toxin. Can produce a toxin. This is another one. We look for specific structures like this at the end of it. Different forms, and we've got filamentous. This is another kind we often see in the river. These are called diatoms, and each of those little circles is one specific cell. And we can also get chains like this where they form little beads. And another type, we've got different filament and a different colonial form. So all these are different kinds of algae that can appear in the river, and in other places, and we keep an eye on those using our microscopy that we have here. As I mentioned, algae can produce toxins, so one of the other analyses we do in the micro lab is we actually analyze for toxins. And so this is our instrument that we use to do that. We put samples in, we have standards, we have reagents, and then the machine actually decides what goes where, and it's an automatic machine, so we don't have to do a lot of pipetting, and then we end up with a toxin result.
Hi, my name is Dawn Webb, and I am the program manager for the Metals Lab here at Greater Cincinnati Waterworks. What we look for are primarily these yellow elements here. There are about 66 metals on the periodic table that we can look for. We generally, on a day-to-day basis, look for two big ones. We look for lead and copper. Copper and lead are both very important for compliance with the EPA rules. There can be some lead in our distribution system, so we do analyze samples from customer homes. There's a cart full right here. We have a lot of them. This is just what we have today, but we've been averaging about 8,000 samples a year for lead. Lead is a big concern with pregnant women and small children. It can cause some developmental delays and some brain damage, so we're very concerned on what the lead levels are and how to help our customers understand that. To give you an idea of how we do it, we get the samples here. We then put them on this instrument. This instrument is called an ICP-MS, or an inductively coupled plasma mass spectrophotometer. It's a big word. And what it does is it's able to elementally break the water sample down so that we can look for just the specific compounds that we need. Based on those results, we're able to give those results to our customers and work with them to either get their lead branch changed out or to use a filter in the meantime until that can happen, and ultimately protect their families and make sure that everything is safe.
Folks, my name is Niranjan Selar. I'm the in charge for the organic lab in water quality and treatment division. Here we have a lot of instrumentation we use to test the water quality of our drinking water. You see the instrument behind me? This is a GCFID, and it is directly connected to our Ohio River water. In case if we have any kind of spill occurs in the Ohio River, this can identify 60 to 70 organic compounds, volatile organic compounds. So every 2 hours we draw the sample from the Ohio River and run through the instrument, and our shift chemists, they work and they come back and then look at the data. If we call early warning organic detection system, that's what we call it as a EWARS. If I identify any compound here, if we cannot identify exactly what the name of that compound, then we go to the sophisticated, much more instrument that is called GCMS. This is a GCMS instrument. I told you, the much more sophisticated instrument. This instrument can identify any volatile organic compounds. Even we don't know the chemical name of the compound, it has a library, it can go back and search and it can identify the compound. Once we know what the compound is, then immediately we'll inform to our management, then they'll take the action. How can we eliminate this, what the problem is, how can we rectify this problem. These are much more sophisticated instruments. This is called GC mass spec. It can identify up to 70 to 80 compounds within an hour, chemical compounds in drinking water. Hello folks, this is another lab, we call it as extraction lab here. And this instrument again, this is a GC mass spec instrument. It can identify 2 chemical compounds. Sometimes people complain about their water smelling bad, especially in the summertime because of the algae growth. There are 2 chemicals. That is, one is MIB, the second one is jasmine. At a parts per trillion, very low level, people can smell. So those are the 2 chemical compounds we can identify with these instruments. So we run once in a week to run these samples to make sure that there are no chemicals in this drinking water for the MIB and jasmine. Those are called as a taste and odor compounds. And here another instrument, it is called as a GCMS-MS, and this can identify pesticides and herbicides. Generally what happens is people use for fertilizers in their lawns. Generally there are atrazine, there's a chemical compound called pesticides, so which goes through in the river. When people wash, everything goes to the river. So this is also can be identified parts per billion level. So that's called pesticides and herbicides in drinking water. Hi folks, this is another instrument. This is called LC-MS-MS. This instrument can identify pharmaceutical and personal care products in the drinking water as well as a PFOA and PFAS. So our management is going to explain you what is PFOA, PFAS, and this can also identify parts per trillion level in the drinking water. It's a very hot topic right now, PFOA, PFAS, and this is a very sophisticated instrument. And we are very fortunate that very few utilities in the country have this many type of instrument, different type of instrumentation, and we can do in-house. If any kind of chemical spill occurs, we have everything ready here to run our drinking water. And we, every day in, day out, we test all the drinking water samples in volatile organic compounds, trihalomethanes, as well as the PFOA and PFAS.